Hello, today we're going to talk about the popular ACT formulas and concepts worksheet that you should be able to easily find next to the link that you found this video. You should have printed off the worksheet. It should be blank, so that way you can go ahead and copy down things that you see from this video. I'm going to briefly, very briefly go through each one of these topics. We're going to cover a lot, and I am going to go fast. Keep in mind that my goal for this course is to not to teach you 4 years of high school math, but to review 4 years of high school math so that you'll be ready for the ACT. So if you need to, pause the video at any time and take notes. Obviously, taking notes is going to help you study for the ACT as opposed to just listening to my voice. All right, we need to probably do both because that'll be good practice and good review. So I'm going to go through each of these things. You can see here, first I have the very top. Statistics is where we're going to start. So if you've got that ready, then we'll go ahead and get started. The first thing we're going to talk about, of course, is the mean. I'm hoping that the mean, the median, and the mode are all review. Remember, the mean is when you add the numbers together and you divide by the number of numbers. That'll give you the average. That's usually what we refer to when we say average. However, the median and the mode are also types of averages. The median is when you order the numbers from least to greatest, you pick the middle number. Remember, ordering the numbers least to greatest is important. And then pick the middle number. If you have two middle numbers, you're going to add those two numbers together and divide by 2. So that's your median, and your mode is the number that occurs the most. And you may have more than one mode in the set, and that's fine. Or you may not have a mode at all. Maybe every number occurs just one time. So then you would write no mode. And last but not least is the range. The range of a set of numbers is the high number minus the low number. All right, I'm going to move to the next slide. Feel free to pause the video and jot that down and then pick up again when you're ready to get going. All right, the next thing, and this is super important when you're referring to the ACT because they are going to mention types of numbers a lot. All right, so they may say in a problem the natural numbers, or they may say your possibilities for numbers are the whole numbers or any integer from, and you need to know what those kinds of numbers are. So this is super important to study. The natural numbers, remember, are just counting numbers. 1, 2, 3, 4, 5, 6, 7. The numbers you naturally start counting with. All right, we naturally start counting with the number 1. So that's why it's a counting number. No decimals, no fractions. Whole numbers, all your counting numbers plus 0. That just makes them complete. It makes them whole, just to add that 0 on. That's the only difference between these two sets. The integers are all those whole numbers and their opposite values. So 0, 1, 2, and 3 all the way up to infinity are there, but you've also got your negatives. All right, so that makes the numbers integers. Again, no decimals, no fractions. Rational numbers, this is where you start your fractions and your decimals. Rational number is basically any number that can be written as a fraction. All right, keep in mind you cannot have 0 at the bottom of a fraction. Dividing by 0 is an illegal move. All right, calculators even freak out when you do that. But basically any number that can be written as a fraction. So 1/3 is a rational number. 1/9 is a rational number. 5 is rational because we can write it 5/1. Pretty much any number that repeats or terminates is rational. And then your irrational numbers like pi, or like square root of 2. Numbers that go on forever, but they do not have a pattern. All right? The key word here is go on forever. And I guess also zero pattern, because 1/3 is 0.3 repeating, and that goes on forever. But it is a rational number because 0.3 repeating is the number 1/3. So irrationals cannot be written as fractions. Imaginary numbers are pretty much all the rest of the numbers that I haven't even talked about. So anything which is usually we'll refer to imaginary numbers as anytime we have a negative underneath the square root sign. So we don't really like negatives underneath the square root sign, and if that happens, we allow it, we just call it an imaginary number. So hopefully you'll deal with that in your Algebra 2 class if you haven't already. All right, just a few basic review items for algebra. All right, slope is rise over run, y2 minus y1 over x2 minus x1. A lot of teachers refer to that as the cheerleader formula. Slope-intercept form, y equals mx plus b. Remember, m is your slope, b is your y-intercept. Point-slope form, y minus y1 equals m times x minus x1. We use that form for a linear equation when we have a point and we know the slope and we're trying to figure out the equation of the line. So you'll use that form, point-slope form, if you're trying to write the equation of the line. Vertical lines, remember, are x equals a number. Horizontal lines are y equals a number. I like to remember those because vertical lines, if you notice, if you can just follow my my arrow right there, you can see there's a V in that, V for vertical. There's also an upside down V right here. Horizontal, I like to turn this Y upside down and it makes an H. Looks just like an H if you turn that Y upside down. So hopefully that'll help you remember horizontal line. All right, next is factoring. Factoring, you're going to first of all always take out the greatest common factor. Here's your difference of two squares, a squared minus b squared. So you have a minus b and a plus b. Your sum and difference of cubes, those are hard to remember, and quite honestly, I think if that's the last thing you do, you'll still be fine. Alright, so this is how you factor a difference and a sum of cubes. Here's your sum of cubes, here's your difference of cubes. If anything, you need to have the difference of squares memorized. So if that was like 81a squared minus 9b squared, then you would do 9a minus b and 9a plus 3b. Sorry, that would have to be a 3. We'll go over that again later, so don't freak out if I'm going too fast, which I completely understand that I am, but I wanted you to get these notes down so that we can use them this semester. All right, reverse FOIL is basically just your guess and check method way of factoring. And factor by grouping is grouping terms together with common factors, and we will practice that also later on in the semester. All right, the distance formula, distance between 2 points, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance between 2 points on a graph. All right, the midpoint formula. The midpoint formula, whoops, let's go back. Somehow I went a little too far here. I'm not sure how I did that. All right, here we go. The midpoint formula, given two endpoints of a line, use x1 plus x2 over 2, y1 plus y2 over 2. If you're looking for a midpoint, then you're going to end up with a point. Notice it's an ordered pair. It's got parentheses. This is your x value, this is your y value. It tells you where to find it on a graph. All right, next slide. This is your laws of exponents. Multiplying, if you notice the bases are the same. If the bases are the same, you're going to add the exponents. If you're dividing, The bases are the same. You are going to subtract exponents. Again, we are going to spend a whole day reviewing this, so no worries if you can't remember it now. Just get the notes down. Power to a power. If you have a base to a certain power and you take that whole expression to another power, then the easy way to do that is just to multiply the exponents. Negative exponent. You have a negative exponent, a to the negative m power. We're going to flip that over and put it 1 over a to the m power. So in other words, it makes the exponent positive when you flip it. And vice versa. If you had the negative on the bottom and you needed to, of course, make that exponent positive, you would put it on the top, which makes it positive. So when it jumps the line, the exponent switches from negative to positive. And then, of course, a zero exponent, the ACT likes to fool people and put any number to the 0 power on there, and then you want to just make that 1 because that's what it is. Any number to the 0 power. So it doesn't matter how big this a value is. Excuse me. This is going to be equal to 1. All right, next slide. Supplementary angles are a pair of angles whose sum is 180 degrees. Complementary, the angles add up to 90 degrees. A little geometry review for you. The next one, the interior angles of a polygon. To find the sum of all the interior angles of a polygon, you take the number of sides minus 2 and you multiply that number times 180. N minus 2 times 180. But if you want to find the exterior angles of a polygon, you just need to remember that those always add up to 360. It doesn't matter how many sides you have. So you might have a triangle, you might have a quadrilateral, a hexagon, octagon, doesn't matter. The exterior angles always add to 360. All right, so let's go on to our parallelograms. Parallelograms, these are 4 basic properties of parallelograms that you really need to know, okay, for the ACT. The first one, on all parallelograms, opposite sides are always parallel. That's by definition of a parallelogram. All right, that seems like a no-brainer. Opposite angles are congruent. If it's a parallelogram, the opposite angles are going to be congruent. Consecutive angles are supplementary, which means that 2 angles that are next to each other are going to add up to 180 degrees. All right, and we'll practice that again in another section. Diagonals bisect each other. All right, the diagonals bisect each other is just a property of quadrilaterals. And then one more thing, just to make a little note here, that the interior angles of a quadrilateral, it doesn't matter if it's a parallelogram or not, those interior angles always add up to 360 degrees. All right, now you could use your n minus 2 times 180 to figure that out, or you could just memorize it. I suggest memorizing it because on the ACT we are trying to go as fast as possible through this test, and it seems silly to have to calculate that when it's the same every single time. The interior angles of a quadrilateral always add up to 360. All right, let's review triangles. Of course, your acute triangle has all angles less than 90 degrees. Your obtuse triangle has one angle that's greater than 90. The other 2 are acute angles. The right triangle, one angle equals 90. The other 2 are acute, one 90-degree angle. An isosceles triangle, 2 or more congruent sides. All right, 2 sides are the same, one side is different. Or it could be equilateral. If it was equilateral, all the sides are the same, then we also refer to that as isosceles. The next one is scalene. Scalene means all the sides are different measure. Every side has a different measure. And of course, the angles of a triangle have a sum of 180 degrees. That probably is a no-brainer to you. All right, next slide. We've got the Pythagorean theorem, which of course a squared plus b squared equals c squared. Notice those are the legs. The two legs are the a and the b, and the third side is the c. And then the special right triangle.